Hello students, this is Miss Dalton, and this video is on solving systems of equations in two variables using three different methods: graphing, substitution, and elimination. Okay, a lot of this in this video is going to review information that you learned in Algebra 1, so it just kind of depends on how much you remember on whether or not this will go quickly for you or if you'll need to take some more time to do it. So when you're solving systems of equations, what you're looking for is the point of intersection. And so the first method that we're going to use is called graphing, where you're going to graph each of the equations and you're going to look for that point of intersection. And that point of intersection is going to be your solution. Okay, so it always helps for your equations to be in the format y equals mx plus b, which in this first example, both of our equations are in that format. When you start to graph it, you want to make sure that you start with your y-intercept. And so for this first graph, my y-intercept is 4. That's going to be on your y-axis, which your y-axis is here. So you're going to put a point at 4. Okay, and then you're going to move according to your slope. Your slope is 5/7, which, if you remember what slope is, it's the rise over the run. So if my slope is 5/7, then that means I'm going to rise 5 and run 7 to get to the next point. So we're going to start at this point 4. And we're going to count 5 going up, 2, 3, 4, 5, and over 7, 2, 3, 4, 5, 6, 7. And that's going to be this point right here. Okay, so let me go ahead and try and draw the line for that. Okay, let me grab this and make it move just a tad. All right, so there I have that line. Okay, let's go ahead and move on to the next one. So this one has a y-intercept of -2, so we're going to put that on there. And then our slope is -1/7. Well, when your slope is a negative, you need to make one of the numbers negative. I always make the top number negative. And again, we're going to rise, so we're going to rise -1 and then run 7. Okay, so let's go ahead and get our line. And then let me extend that line. Oh. Okay, so we can see that it crosses right here at -7, -1. And you can always double check that by plugging it in to make sure that it works. So if I plug it into this top one, I would have -1 equals 5/7 times -7 plus 4. Well, this would cancel with this, make that -1. So you'd have -1 equals -5 plus 4. And that does, in fact, equal -1. Then we could check it in the bottom one as well. -1 equals -1/7 times -7 minus 2. That would give me -1 here. So -1 times -1 is +1 minus 2. And that does, in fact, equal -1. So again, your solution for this one right here is going to be the ordered pair where they cross, -7, -1. All right, let's move on to this next one. Now this next one is not in slope-intercept form. So that's the first thing that you would have to do, is you have to get your y by itself. So I'm going to subtract 4x from both sides. Whoops, 4x, not 4y. And then you're going to have negative 2y equals negative 4x plus 8. And then you're going to divide everything by negative 2 to get your y by itself. So you'd have y equals negative 4 divided by negative 2 is positive 2x. And then 8 divided by negative 2 is minus 4. So go ahead and start with your y-intercept. Your y-intercept is negative 4. Now, with your slope being a whole number, 2, remember that's 2 over 1. So we're going to rise 2 and we're going to run 1. And so here's our points. Let's go ahead and connect those. Extend it a little bit. Okay. Now, when we graph this next one, y equals negative 2, this has a y-intercept of negative 2, but this is one of those special lines where it's either horizontal or vertical. Well, this is going to be horizontal. It has to go through your y-axis, so that's going to be a horizontal line. And you're going to see that they cross right here at 1, negative 2. Now we're going to trust that that is the solution, but again, you could plug it in to make sure that that works in both of your equations. All right, the next method to use to solve by elimination is where you're trying to get one of your variables to cancel when you add your equations up together. So what you need is you need your coefficients of one of your variables to be opposites. So if you look at this first one, if I want to try and get my x's to cancel, okay, this has a coefficient of 10x. This has a coefficient of negative 5. Sorry, not 10x, but that has a coefficient of 10. This has a coefficient of negative 5. If I can get both of those to be opposites, and then I would be able to add them up and cancel them. Well, is there a way that I could get the bottom one to turn into a negative 10? Because that would be an opposite with 10. Well, the way that I could do that is to multiply this bottom one, multiply the whole thing by 2. Okay, so then what you'll have, the top one will be the same. So 10x minus 8y equals 4. But the bottom one, you're going to multiply everything by 2. So you'll have negative 10x. 2 times 3 is 6y. And 2 times negative 9 is negative 18. And elimination, you add your equations together and you get one of those variables to cancel. So now you'll have negative 2y equals negative 14. Divide both sides by negative 2. And that gives you a y value of 7. Okay, well now, since you have that y value, you're going to plug it in to either equation where you have a y. So let's take the bottom equation, because it has smaller numbers, and let's plug in y of 7. So negative 5x plus 3 times 7 equals negative 9. So negative 5x plus 21 is equal to negative 9. Subtract 21. That gives you negative 5x equals negative 30. And if you divide by negative 5, that gives you a value of 6. So our solution for this system of equations, always put your x first, 6, 7. So if we were to graph these, we would see that they cross at 6, 7. All right, let's move on to the next one. So this one, we would want to get, and again, you can do either variable. I could do these and get these to be opposites, Or I could do these and get these to be opposites, whichever one you want to do. Now, I think I'm going to try and get the x's to cancel because all I would need to do is multiply this bottom one by 3, and then now I'll have the coefficient of 3x, and then that would cancel with the top one. So let's go ahead and copy down our top equation, negative 3x minus 10y equals negative 4, and let's multiply the bottom one by 3. So positive 3x minus 15y, and then 18 times 3 is 54. Add them up, the x's cancel. So negative 10y minus 15y is negative 25y equals negative 4 plus 54 is 50. And then divide both sides by negative 25, so y is equal to negative 2. And now let's plug it in. Now I'm going to plug it into this bottom equation right here where I see y. So I'm going to have x minus 5 times the y value of negative 2 equals 18. So that gives you x plus 10 equals 18. When you subtract 10, you get that x is equal to 8. So your solution would be your x value first, 8, negative 2. Again, don't be afraid to plug these in. It should work in both equations if you have done it correctly. All right, the last method is called substitution. We call it substitution because we're trying to get one of our equations to substitute into the other one. And so in order to do that, you have to solve one of your equations for one of the variables. If I look at this first one, my y would be pretty easy to solve for. What that means is I would need to get that by itself. Okay, well, to do that, I would just have to add 8x over to the other side. And now I'll have y equals 8x minus 12. And so what you do for substitution is you take this equation now that you've solved for y, and you take this value that you got for y, and you put it in place of the y in the other equation. So you're going to have 4x plus 3, and in place of the y, I'm going to put in 8x minus 12. And that's equal to negative 8. And now you just have one variable that you can solve for. So 4x, 3 gets distributed, so plus 24x minus 36. And that equals negative 8. Combine like terms, 28x. Let's go ahead and add the 36 over to the other side. So that gives you 28 on the other side, so x is equal to 1. Now, once you have your x value, go ahead and substitute it in to this equation right here. And really, you can use either one, but it's just easier to substitute it in there. So you're going to have y equals, whoops, let me change that back to a pen. You'll have y equals 8 times that x value that you just found of 1 minus 12. So that's going to be 8 minus 12, which is negative 4. So your solution is the x value 1 and your y value negative 4. Okay, let's move on to this next one. So in order to do this one, the variable that would be easy to solve for is this y, okay? But again, you can solve for any variable. It's just, I usually tend to look for one that has a coefficient of 1. And so all I would have to do here is I would have to add 7x to the other side. And so then you'd have y equals 7x minus 23. And now we're going to take the 7x minus 23 and we're going to plug it in up here for y. So you'll have 14x minus 2 times the y of 7x minus 23. And that's going to be equal to 46. So you'll have 14x, distribute the negative 2. So you'll have minus 14x, and minus 46 equals 46. No, sorry, that's plus 46, sorry. Okay, well, okay, this is going to be a special case, because look what happens. 14x minus 14x, those cancel. So then you have 46 equals 46. Okay, this is a true statement. And so what you want to do is you want to look and see if when it becomes a true statement, then this equation is the same as this equation. And you can see that it is, because if I took this bottom equation and multiplied it by a negative 2, I'm going to get that top equation. So negative 7 times negative 2 is 14. Y times negative 2 is negative 2y. Negative 23 times negative 2 is positive 46. So that means that they're the same equation, which when I graph them, they would end up right on top of each other. Okay, so this is what we call infinite solutions. Everywhere that they cross is a solution. Well, it's going to cross everywhere because they're the same line. Now, we have another special case, which would be if the lines, when you graph them, they become parallel. Well, are they ever going to cross? No, they're never going to cross. And so when they're parallel like that, this would be an example of no solution. And so what's going to happen when you have a no solution is you're going to have, your variables are going to cancel. But when you get down to this statement right here, it's going to be a false statement. And if it's a false statement, then it's no solution. If it's a true statement like it was here, that's going to be infinite solutions. Okay, so look for those special cases. Sometimes you have one solution, but you could also have infinite solutions, and you could also have no solution. All right, so hopefully you remember this from Algebra 1. Please do the assignment and let me know if you have any questions.